recording started. 8 to the first power b, we don't normally see that power exponent of 1, right? We know that we don't see it, so that's equal to 8, right? 8 as a single factor. So the base, the big number, here is called the base. We talked about this last week. This is the exponent. The base is the factor. The exponent tells us how many times it's a factor, right? How many times we're multiplying it by itself. And we're going to skip C, so let's look at D. Make it a little bit bigger. I don't know how well you guys can read yours. I think they're pretty tiny. I'm going to work on trying to make this a little bit bigger. Your notes, typically, my plan is just to have your practice problems on there, and we'll add things in, or you can add things in that help you, remember how to do something, or remember a definition, or whatever. But I am going to try to make them a little bit bigger on your copy. I'm working on that. I'll have to kind of tweak that as we go. All right, so 1/2 is the base. 5 times is how many times it's going to be multiplied, right? Those are 2s. I know they don't look like much, but those are 2. So multiplying fractions, multiply all the numerators, we're at 1. Multiply all the denominators, and we're at 32. One more thing to remember when you see a fraction raised to a power. So it's also equal, that could be rewritten as, let's see, with 5, might be. So we can rewrite this as 1 to the 5th power divided by 2 to the 5th power, right? Same thing. Sometimes it helps us to be able to do that. Questions so far? All right. Let's look at A and B. We talked about this last section, but I think it bears repeating. -3 raised to the 4th power is not the same as the opposite of 3 raised to the 4th power. So this is -3 as a factor 4 times. So we're going to put the parentheses there. And that equals 81, I believe. Positive 81. So if you have a negative number with an even exponent, when you evaluate that exponent, it should be positive, right? An even number of negatives gives you a positive answer. If you have a negative number and an odd exponent, odd-numbered exponent, you should have a negative product when you're done. This is the same as, so for B, I'm going to write it down here. It's the opposite of 3 times 3 times 3 times 3. You could also write it as -1 times 3 times 3 times 3. So those would indicate the same thing. So then it's going to simplify to -81. Any questions? Right. And if we're evaluating more than one factor with a power, it does. Remember that multiplying a power times a power here. If we had like bases, we could use a shortcut, but the base here is -2, the base here is 5. So that's the same thing as -2 as a factor 5 times, and 5 as a factor 2 times. I know that this is going to be a negative something. Two times 2 times 2, what is it going to be? Oh, it's just 3. Okay. That makes my math easier. I do appreciate you correcting on that kind of schedule. Everything gets a lot more confusing when I write something wrong and I've got kids going, wait, what? Is that, did you mean, am I doing something wrong? So thank you for catching my careless mistake. So this is -8 times 25, so we had -200. All right. talking about negative integer exponents. Remember, negative integers indicate that it's a reciprocal. So we're going to multiply by the reciprocal. So instead of dividing or having that negative, so a negative exponent indicates a reciprocal. And remember, for us, what that means really is that we're moving. Anytime we have a negative, after we've simplified, evaluated powers to powers and all that, if we have negative exponents in our expression, then we want to multiply by the reciprocal of that positive exponent, right? So the way that in practice that works is if we have a negative in the top, we move it to the bottom and make it positive. If we have a negative exponent in the bottom, once we're done simplifying everything, we move it to the top to make it a positive exponent. Not a positive number. When I said negative there, make sure you know that it's a negative exponent. Negative numbers don't matter. We can't, and we don't just move them, obviously. All right, so for A, 2 to the negative 4th power. For something with just that one power, that one exponential expression, I would just go ahead and move that to the bottom. So remember, 2 to the negative 4, you can make anything a fraction by putting it over 1. So 2 to the negative 4 over 1, we move the 2 to the 4th power to the bottom and leave this with 1 in the numerator. So that's going to be simplified to 1/16. So looking at B, the negative exponent is in the denominator. Well, we can't leave the negative, so all we're going to do is we're going to move that to the numerator. So 3 to the 3rd power, if you don't have anything in the bottom, you can put the 1. But we're going to simplify that. So remember, that's not a negative 3, right? And that's going to simplify to 27. When you're doing your homework tonight, please write the problem. Please box your answer. I do need to see some work. Frankly, I don't need to see this work, okay? I don't need to see this work. I don't need to see order of operations work anymore, really. But I do need to see a little bit of work when you're simplifying. I'd like to see at least that you've listed here. Does that make sense to everyone? All right, we're going to do one at C or D. All right, so let's do, which one do you see? You can write yours down here. I'm going to write mine up top a little bit bigger so you can see it. 4 to the negative 3rd power times 1 over 2 to the negative 4th power. I'm just going to go ahead and give myself a fraction bar. Remember, that's in the numerator. We could write that all as one expression. So 4 to the negative 3rd power, we need that to be a negative. We're going to put 4 to the positive 3rd in the bottom. That's like multiplying by the reciprocal. And the negative 4 in the denominator, then, in order to make that a reciprocal, we're going to make that a positive exponent in the top. So that's 16 over 64, and so that's going to simplify to 1/4. Any questions? All right. Anything raised to the 0 power, you guys remember that one? What that is? What is anything raised to the 0 power, guys? The answer says 1 and the answer is right. So it's any non-zero number, anything except for 0. So any non-zero number raised to the 0 power equals 1. So 5 to the 0 power is 1. Now, let's look at B. 1 over 2 to the 0 power. We evaluate that, remember the fraction mark like a grouping symbol, right? So we would evaluate that as 1/1. Sometimes you might have something different in your numerator, right? This expression is going to wind up simplifying to 1, but if this were 4 up there, it would not, right? Does that make sense to everybody? Remember, the exponent only applies to what is directly to the right of, unless there's if there's grouping symbols, then on the outside, the exponent on the outside of that, it applies to everything within the grouping symbol. So -3 and 0 power, also 1. What is D simplified to? Is that also 1? Zachary says it's -1. Why is it -1, Zachary? Perfect. So this is the opposite of 4 to the 0 power. So that's actually -1. So far, so good? All right. All right, so we're simplifying exponential expressions. So we're starting with multiplying and dividing. Then we're going to go to be moving on to review powers of powers as well. Remember, let's look at A. I'm going to make it bigger. Okay, so for A, remember, we don't need these grouping symbols because it's all multiplication. I can rearrange any of these factors. These are all factors. Everything here is being multiplied. Doesn't matter if I'm using grouping symbols. Doesn't matter if I switch to order. Really what we're looking for here is we're looking for like basis, right? We're looking for little shortcuts. Not like terms, right? Like basis. When we multiply like basis, we can make a shortcut. So constants, we know we can definitely always multiply constants. So we're going to start with -2 times -5 is -10. I'm going to have a bunch of these things. I always cross them out once I've simplified it so I make sure it gets included in my answer. Like bases, x's and x's. Remember when we multiply like bases, our shortcut is that we can just add their exponents. So that's going to be x, so 2 to the 3rd power, so x to the 5th power. Y does like bases of y to the 3rd power times y to the 1st power means that we can add those bases, so it's y to the 4th. So when we're talking about like bases, to multiply, we add the exponent. While we're at it, to divide, we subtract the exponent. So for A, that simplifies to -10 times x to the 5th power times y to the 4th power. Now, for let's go ahead and do C, because that's dividing like bases. We're going to make it a little bit bigger here. Like that. That's x to the 3rd power. I'm using a dividing tool. On here, we're going to say that's a 3. But it's funny that some of the equations or algebraic expressions are clearer than others on there. Okay, so fraction, remember, means we're dividing. So any constants, any coefficients, we just simplify those like normal. So 25 divided by -5, we should know that that's going to be -5, right? But we made a note up top, when we're dividing like bases, we subtract those exponents. So 3 minus 5 means that's going to be x to the -2 power. Like bases is y, for dividing y to the 6th and y to the 4th, we're subtracting top minus bottom. There's a ton of ways to evaluate these and simplify these expressions. I suggest you pick one way and do it the same way every time. That is what I try to do. When I don't, or when I get in a hurry, these are not hard, but they are tedious. and that can cause you to make a mistake on something that you really know how to do. All right, and now we do not leave negative exponents in a simplified expression. So now we are going to convert this to a fraction because we need to move that. Remember, that is like being over 1, right? So we're going to move that to the denominator. And we have negative 5y squared is what that expression simplifies. You with me, Aspen? All good? All right. And then a power to a power. So b is a power to a power. Let's add somewhere here at the bottom. If you're raising a power to a power, let's say, raising a power to a power, we're going to multiply the exponent. So just in case you didn't spend all summer reviewing these rules, shortcuts, multiply the exponent. So we need to review this basic stuff so when we get to stuff that's more complex, you're comfortable with this, you've been using it, you've been practicing it, and it's not going to keep you from being successful at the other things we're working on. All right, so b is 2x squared y cubed, all raised to the third power. So my suggestion to you is always raise the power to power, and here that's really kind of all we have to do is raise power to power. But we're going to do problems like over here, raise power to power first, then do your like bases, then move things around. That is my suggestion to you. Angel? You're right, I did. Thank you, Angel. Okay, so the thing that kids forget, and partly because there's no exponent on that 2, or if you don't see it, there's an exponent of 1. So we're multiplying 1 times 3, 2 to the third power. 2 times 3, that's x to the 6th power. Y also has an exponent of 1 if you don't see it. 1 times 3 is y to the third power. And z to the third power raised to the third power is z to the 9th power. And now we're going to simplify that to the third power. So it's 8x to the 6th, y to the third, z to the 9th power. All good? You already wrote it down, Joel? Okay. So we're just practicing pretty much all the things that we've done already. Looking at A. Is that big enough everybody can see that now? I don't have to rewrite it. Okay, so we're going to look at A. Distribute that, or raise that, everything inside the grouping symbol to the power. So 3 to the negative third, x to the 6th, and z to the 12th. Keep up with your negatives. It'll get you. And I didn't keep up with mine. Negative third, that's 2 times negative 3, so that's negative 6. Negative times negative is a positive 12. So now I have 2 negative exponents. I know I need a fraction. So I'm going to move everything that has, or that finger being over 1, everything that has a negative exponent is going to go in my denominator and make that exponent positive. Whatever is not negative, leave where it is. So our final answer for A is x to the 12th over 27 times x to the 6th. With me, Ethan? All good? All right. And we're only going to do one of these two. They're pretty similar. You guys got all this? Okay. We'll just see. So I'm going to raise everything. So everything in the numerator to the power, raise everything in the denominator to the power, and then multiply, divide, like basis as needed. So this is negative 2 to the third power. So that's going to be negative 2 to the third power. It's inside the grouping symbol. X to the third power and y to the second power. Notice that this negative is outside. If you want to put a negative 1 down there, you can. Negative 1 or just a negative. Everything inside the grouping symbol gets raised to that exponent. Is that also the true or limit 2? Other way 3. So that's times 6 to the third power, x to the third power, and e to the ninth power. We're going to value all that. That's, yep. Oh, Jewel caught my mistake. 2 to the third power should be 2 to the sixth power. Good job. Easy. It's not hard, right? You get in a hurry, you get to the next part of the problem, and you can mess it up. It's always good to go back and check. So did I get this one right? 6 to the third power, x to the third power, and then z to the ninth power. Okay. This is going to simplify to negative 8. Remember, it's not a negative exponent, so it stays where it is. And negative 1. Now we're going to evaluate. So a couple ways to do it. I'm going to take this parentheses out. We actually don't need this. So that's the same as negative 1 times 6 to the third power, right? So that's going to be negative, what's 6 to the third power? Can someone help me? 216. So negative 216 in the denominator. Like basis x's, x to the third power minus x to the third power, x to the 0 power. So that's 1, right? So I don't need to include that. And now I have y to the 6th power minus y to the, sorry. Oh no, I don't have y to the 11th power. So the y stays the same, the y stays at the top, and the z stays in the bottom. So we have less in the numerator, negative 8 times y to the 6th power, negative 216 times z to the 9th power. So a negative divided by a negative, and we're going to simplify 8 and 216. 8 is 8 times 216, 8 how many times? 27. Alright, so it's over 27. So we could put the 1 up there, but we wouldn't leave it there, right? So it's y to the 6th power divided by 27 times z to the 9th power. Questions so far? Okay. Caught up with me? We're writing, but are you writing it in scientific notation or are you writing where we are? Okay, I don't want to rush people, so if you're working ahead, I don't know, I'm waiting for you to get done with the example that I'm working on, and if you're working on the next one, then I'm just standing here waiting for notation, right? All right, if we want to write a number written in what we would call standard form, or expressed as a decimal, we want to write that in scientific notation. So remember the form for scientific notation. So it's a base times the power of 10 raised to some power, right? So scientific notation means we're multiplying some base, we're rewriting this as a base or a factor times a base of 10 raised to an exponent, right? Remembering that this number, C is going to be greater than or equal to 1 and less than 10. And I know you can write that as a little sandwich form, but that's written in your book. You can read it that way. But this number can be 1 or greater, but it's got to be less than 10. Remember that numbers greater than 1 are written with positive exponents. And numbers less than 1 are greater than or equal to are written with exponents on the base that are negative. All right, so I know I need a base times some factor of 10. So my number is going to be greater than or equal to 1. So if you don't see the decimal, remember always to the right of the last digit if there's not a decimal. How far do we have to move back until we get that C, that number, that factor that falls within this range? So starting here, that's 3, 6, 9, 12, 13, 14, 15. 3.856 falls within that range, and that's a period, not a comma. And I moved it back 15 places, right? So that big number can be written in scientific notation as 3 and 856,000 times 10 to the 15th power. Positive exponent is the number we started with greater than or equal to 1. We know this is going to have a negative exponent because it's 0 directly to the left of that decimal point. So it's going to be some number times 10 to some negative power, right? And it's going to be a negative power. So starting here, how far do we have to move our decimal point to get a number that falls within that range? So 1, 2, 3, 4, 5, 6. 2.75 is greater than or equal to 1 and less than 10. And I moved it 7 decimal places, 1.6 decimal places. And so in scientific notation, that's 2 and 75 100 times 10 to the negative 6 power. We're going the other way, going from scientific notation to decimals. For this exponent on the power of 10, if it's positive, we know we're going to have a number greater than 1. And we know there's going to be 5 decimal places. So here there's already 3 decimal places, right? There's going to be 2, 8, 6, 9. This is a decimal point here. 1, 2, 3. I need 2 more decimal places. I need 5 decimal places. That's what that 5 tells me. Does that make sense to everyone? I know this number is going to be less than 1. Which way do I have to move this decimal point to make it less than 1? I got to move it to the left, right? If it's negative, I know it's got to be less than 1. So decimal point is here. We're going 3 places. So 1, 2, 3. Add 2 places. And so 103 10,000 is the same as 1.03 times 10 to the negative 3rd power. All right, I gave you some pretty basic examples in here. You're going to apply these rules to some that are a lot more tedious than these are. You do have time. You still have almost 20 minutes. You can work on your homework. Remember, write the assignment, pages 24 to 25, on your home page. Also, in your module, 24 to 25, 2, 6, 16, even. That's how your paper should be headed, along with your name and today's date. I think it's a pretty good consensus. Most people prefer ice cream over cake. I'm one of the rare ones. But I'm at a birthday party, I want the cake and not the ice cream. It is that one, I found it. If you would sign out, Angel. But today is the 24th. You're going to write that and your name, your time, the time you left, the restroom, and when you get back, the time you left. That's wrong with that grant. Yeah, I should tell the rule only one that I cost for the cash. Every once in a while, I'll break that rule instead of make the office or the clinic, but I try to be a rule follower, Grant. Keeps me out of trouble.